Hi guys, this is a third part of data link layer, the second layer in computer networking. If you want to know what is the data link layer, you can watch my part 1 data link, and as well about the stiffing, bit stiffing in part 2. Now we go to the part 3, error handling. Sometimes when we send through these data, we know that in the data link layer we have the frames. Sometimes when they send a frame with a specific binary code, the signals have something noisy, or maybe is distracted from something that it doesn't send it properly or receive it properly. That will called the transmission called error handling. But how we can be corrected this error, or how are we able to prevent that error happen? We have to deal something called redundant data. Redundant data is added to the message BTB allow by what we need to. If we have error happen in the frames when transmission the frame or the data, then what we need to do, detect the data and corrected the data at the destination, and this is called error correction. The detected the error as subsequences retransmission, that called error detection. So we have error correction and error detection. The error correction is require more redundancy because it's gonna be we send in that data, extra data, and we look for these data and we try to correct it. And as well for detection, no, they go and just see these data. If we have a missing messages and we don't know if that error or not, then we have to send more and more until we found the better one until we corrected. And this is error correction. Sometimes use the poor link, so it'd be hard to be go and detect corrected. So we must be supplemented by error detection and retransmission. So that will occur more than ISO layer. The second type to be able to correct is a partial bit. The partial bit is considered to transmitted without redundant data. So we have redundant data to be correct the error, but sometimes we don't need to have a corrected data. We need to use something called party data, and the party data is when we have to use the two types of party data, even or odd. So if we have in the binary number the number of ones, because we know in the binary we have zeros and ones, if you have the number of ones, it's be odd number. Like number of ones is odd number, then we need to add 0 to keep it as odd in odd binary, in odd partial bit. But if the binary in even number, if in odd party, if we have got even number, then we need to add 1 to make it odd. In odd party, we have the number of ones should be 1. In even party, the numbers of ones should be 1. It should be even number. So let's see this example in even party. So we have 0, 1, 0, 0. So that it's only once 1 we have. So we need to turn even. So we have to add number 1. But here we have 1, 1, we have 2 ones, the even number, so we have to add 0 only in the end. The same thing with odd. We have 1, 1, even number, so we have 1 to be able odd. We have 1, 1, we have 0 to be able to make it, keep it, to make 0 to make it even. So to make it odd, this is the difference between this is how to use the party bit, where I need to know what the type of the party to be able to add the number. The third type to do the correction of the transmission, the data, is called checksum. It's called checksum. Checksum performs mathematical calculation on the sequence of number within the data frame and recorded the result in header. So let's see. how do you deal with that? So for example, if you have got, this is the binary with this number, with a lot of binary 1 0 0 1 0 1 1 0 0 1 1 1 1 0 0 0 1 0, more than these. The first step we need to do, we need to break into the 1 2 3 4 to the categories, and each category should be have go 8 bit of binary. So the first 8 go to the category number 1, the second 8 go to the category number 2, the third 8 go to the category number 3, the fourth 8 go to the category number 4. And even if you have go more numbers here, then we add the category number 5. Then what we need to do, we need to add these binary number, the 1 2 3 4, the 4 categories, each one they have got 8 numbers. We have to add them together as the sum binary addition process. And after we add them, we have to find that number, like 0 plus 0 plus 0 plus 1 give me 1, with odd number 1, with an even numbers 0, then we give me that. Then in the end we have to find this result. Then after we add them, we take that result to add it with these 4 binary, and we'll have go, the result will have go as the fifth one, the fifth character. And with fifth character we need as well to add it, and in the final we should have go all 1. So 1 1 1 1 1 1 1, 8 bit of ones. If we have gone the final 8 bit of ones, that means there is no any error. If we have any 0, that means we have error to detected. That's called checksum. So the checksum is detected all the error involving an odd numbers of bits, and it detected must be error involving to even number of it, so odd and even. And we will see how many scheme of damage it can be corresponding to the bit by bit. Okay, so this is the end of the part 3 of data link layer. If you have any questions, please put in the comment. If you like my video, please subscribe to my channel. Thank you, and see you in the part 4. Thank you.